Hello friend, my name is Derek Carter, and in this video we're going to continue our discussion from chapter 2 of our material for our course. We're going to be looking at the input statement. So the input function, at this point, if you've been following these videos, we've only looked at the print statement so you can get output to the terminal, but we haven't looked how to get input. And also we're going to look at some more advanced ways of doing formatted output. So we're going to use F strings in this video. All right, with that, let's go ahead and get started. Okay, so let's start real quickly with the input function, the built-in Python input function. So I think we've seen some examples of this before, but just real quickly, input like print is a built-in function. So the input statement normally takes a single parameter or string as input. So this will be the prompt. So on the right hand side here, we see that the prompt is going to be what is your name, and input actually returns a value. So unlike the print statement, we didn't really use print statement wasn't really returning anything that we use. So here, what gets returned from input is going to be a string. Okay, so let's take an example of doing that real quick. So here, if we run an interactive session and do that real quickly. So since input returns a string result, if we invoke the input function, whatever the parameter is will be what the prompt is. Notice, another thing to notice is that if you put in space, it will keep all the space. So it's only until you hit return. Everything that you type in until you hit return is going to be returned from calling the input function here, right? So if we look what was assigned into the name variable, we've now got Derek Harder, right? And by the way, the name is a string type, right? So the input function always returns a string, but very often we need to get numeric data from the user, so not just string data. So we need some way to convert strings into like integers and floats. That'll be the most common thing that you'll be doing in this class for the assignments and things. Okay, so there are two other built-in functions, int and float respectively, that take a string as input. So on the slide I probably should have indicated there's really a string data type for both of these, and then they return a converted int and float respectively. Okay, and by the way, so we'll show here, but this is, I think, our first example of a nested function call. So let's show what we mean by that. So here in this Python script that's in our chapter 2 set of code, so we have some examples of using the int and the float, right? So we want to get the name, but we want to actually get an age as an integer and their income as a floating point value, right? So notice what we mean by a nested function call. So input is going to return a string, right? And then that string is passed to the int function, which is what it wants. And we'll convert it to an int and save that into age. And same thing for this one, which will convert to a float and save that into income. All right, so we can run the script like this. We'll say the age is that, and we'll say our income is that. All right, so notice I didn't have a chance to convince you, but we should have, on the script, maybe we should have displayed what the types were for these things here. So let's do that real quickly. So for example, just to show that the age and the income were actually modified, or were actually converted to ints and floats respectively here, right? So we do our name again, age, and income, and so these outputs are coming from the type of the age here was int, and the type of the income was a float, as we should expect. One other thing before I move on from this, these conversions will fail if you don't give something that it can actually, if you don't give a string that can actually convert. So So if we say something like 42, but as words, so the ints and the float can only convert strings that are in a particular format, that are in particular standard literal integer or literal floating point format. Right? So if we do that, we'll actually get an exception, a value error is going to be thrown in that case. Okay. So in a previous video, we talked about, primarily when you're writing programs, you're going to be getting input, doing some calculations, or processing it, and then showing the output results, right? So let's go back and talk a little bit about performing some calculations here, right? A little bit more detail. So typically, a lot of the stuff we'll be doing in our class is performing mathematical calculations. So the standard operators that you'll need are the things to do addition, subtraction, and multiplication and division. A couple of other ones that you'll probably use a lot are like the percent to calculate the remainder. We'll show a quick example of that if you're not familiar with it. And raising things to an exponent. So 2 stars means raised to a power or an exponent instead of doing multiplication again. And there are actually 2 types of divisions in Python. So if you use just a single slash, you're going to get floating point division, even if you use 2 integer numbers, integer values. But if you really want integer division, you should use the double slash. Okay, so let's see some quick examples of that. Before I run into some examples, also just a word about operator precedence, okay? So you might remember kind of precedence from like a math class long ago. So those things will matter when you're trying to write mathematical expressions in a high-level programming language like Python. So Python has pretty much the same order of precedence that you'll find in most high-level languages. So the highest level is going to be parentheses. So if you absolutely need to ensure that a particular expression is evaluated before anything else, just enclose them in parentheses. After that, the next highest is exponentiation, so raising things to a power, and then multiplication and division are the next highest in precedence, and then addition and subtraction. Okay. Anything that has higher precedence would be performed first if you write this out as an expression, and things of the same precedence are going to be evaluated from left to right in the expression. Okay, so let's see some examples of that. Okay, so first of all, just using an interactive session, just a few words about some of the operators that you might not be as familiar with. Okay, so I assume people know kind of what we mean by doing multiplication or something in an expression, or addition or subtraction. So we mentioned that there's 2 different kinds of division operators. So let's say that we have an expression like 7/2. Okay, so here I'm using integer literals. So these would be interpreted as integer values by Python. Right, so if I said y equals 7, it will parse that, it will read that in and store it, represent it as an integer type. Okay, but if you use the straightforward division with just a single slash, you're going to get an actual floating point result. Right? So it's actually a float value. Right? If you really want integer division, which sometimes you do, you'd use 2 slashes. So this forces integer division, even if the numbers aren't floating point numbers. Again, let's do it first with that. So here, the integer division of 7 divided by 2 is it goes in 3 whole times with a remainder of 0.5. So we end up with an integer result of 3. So even if you do that, like, so this is still going to go in 3 times with the remainder of more than 0.5 this time, right? Yeah, I wasn't expecting that. So it done integer division, but we actually got a float result. But the result can still be interpreted as an integer. So I didn't realize that wasn't quite what I was expecting there. So yeah, it kept y as a float in that case, even though we asked it to give kind of the whole amount from performing the division there. And then that, also we can talk about the remainder, or the remainder function. So when you're doing integer division like this, there's something left over, right? So and that's what the remainder does. So when you do 7 divided by 2, it goes in 3 times with a remainder of 1, right? Well, the 2 times 3 is 6, so there's 1 left over when you do the remainder there, right? So that's what the modulus operator does for you, right? So you'll need that a lot for a lot of our assignments. So for example, if I want to test if something is even or odd, I can do the same thing I did there, right? So anytime the remainder is 0, that indicates that it was an even number. And anytime the remainder is 1, when you check the remainder of divided by 2, then indicates you have an odd number there. Okay. So let's talk a little bit more about converting mathematical expressions to Python programming statements. Okay. So you may kind of half remember from taking math classes sort of how algebraic expressions like the left-hand side here work. Okay, so you have to realize a couple of things, and these have to do with how precedence works and kind of the conventions of a mathematical expression versus how you would specify it in Python. Right? So. So, for example, we interpret the first expression here as 3 times, so multiplication or times is inferred when you took an algebra class, when you have expressions like this. So this is the result of 3 times x divided by 2. And since multiplication and division have the same precedence, you don't really need parentheses here. You should get the same result either way. So for example, if we, let's say x equals 5, so in this case, either, if you do the multiplication first, 15 divided by 2 is 7.5, or you could take 5 divided by 2, 2.5 times 3, right? So you should get the same thing either way. Here we're showing using parentheses to force it doing it in the particular order, right? So here, since parentheses have a higher precedence, it will do the division first before it does the multiplication. Here, we're ensuring that it's doing the multiplication first before the division, right? Likewise, here for the a equals x plus 2 over b minus 1, you kind of, if you ever took an algebra course, intuitively understand that really the stuff above and below a division, when it's represented like this, should be done as a group, right? So if you just wrote out this expression, so again, if we have like x and b, let's say x is 5 and b equals 1 here. So if we wrote that expression as like a equals x plus 2 / b minus 1 from the previous slide here, if I can jump back real quickly, so we're working on this one here. But this will have a problem because since the division has higher precedence, it will do the 2 divided by b here, which is 2, and then do the rest of the thing here. The result of this really should, I selected 5 and 1 because it should be 7. I wanted b to be, let's say b is 8. Right? So the we know that the way it was written on the slide is it really should be 7 divided by 7. We should get a result of 1, right? So that means in this case, it is essential in order to get the correct result that you would expect for that expression as shown, you actually do have to specify the precedence. So the x plus 2, the addition and the subtraction should be being performed before the division operation in this case. Right? We get a 1.0 as expected there. And then, finally, like here's something that we might run across in a class like this, like doing like a quadratic expression, 3x squared plus 4x minus 5. Right, so this is an example of the exponent being done here. So let's say x currently has a value. Let's change x to be 3 here. So 3x squared plus 4. Again, some people, when you first do these, might write statements like this. Those aren't syntactically correct because the multiplication in mathematical notation is inferred or implied here, but that's not how a mathematical expression in Python or most high-level languages work. You explicitly always have to state the multiplications, right? So, but here we should get the same result without using any parentheses, the correct result, because the exponent, the power, has the highest precedence, and that's correct. We want to raise whatever x is to the square power first. The multiplications are the next highest precedence. So the 3 times that and the 4 times that will be carried out, and then the addition and subtractions would happen. So we get the result. That should be what we expect when we have x as a value of 3 here. So we should get 3 times 9 plus 4 times 3. So 9 plus 12 minus 5. 21 minus 16 there. Or, yeah, that's right. So 3 times 9. So 27 plus 12 gives you 39, minus 5 gives you 34. All right? So one other kind of example, so we normally think of doing calculations on numerical data types like ints and floats, but sometimes in high-level languages like Python, you'll actually have operators defined on other non-numeric types. So just as a quick example, concatenation and repetition are actually defined on strings in Python, right? So just real quickly, so if we have a string I'll just call it S. If you use the plus, I'm on purpose putting a space at the end of these, right? So I had a space at the end of my first string. Now I'm going to add in, so I'm going to concatenate. Basically, I'm going to be appending the string onto the end of this one, right? Notice I meant to maybe mention this before when we talked about variable assignment. So notice this isn't assigning anything. This did the concatenation, and when I run it interactively, we see the result of the concatenation, but we didn't save that anywhere. So if I want to save that, I can always do an operation and save the result back into something I used in my expression. So the result of concatenating hello and world will be saved back in as a new value to S here, right? So now we've got that in there. And then, I mean, sometimes you might find this useful, that you can also do repetition of a string. So if I want to repeat a string 3 times, I can use the star, like multiplication, but for strings, it's doing a repetition operation. Okay, and finally in this video, a little bit more about some of the advanced kinds of things you can do with the print function in order to format your output. Okay, so first of all, the print function itself takes some other parameters besides the strings that you want it to display on standard output. So in particular, you can add in an argument end or an argument delimiter to modify its behavior. So let's show examples of how those work. So I can specify the end of a print statement we'll say that I want to end with X. So the default is to end with a new line. So if we hit an X, so this is a little bit subtle here, but notice that I didn't end up with a new line after I printed that out. My prompt ended up on the same line here. So instead of the normal new line character, we output the X. So this can be useful if I need to output multiple statements. We might have to do this in a script here. But if I need multiple statements that run on the same line, we can use the end character here. So just as a quick example for a script, if we use the end, I can have multiple calls to print end up displaying on the same line, which can be useful. Sometimes you need that for some of our assignments. Okay, so here, since we didn't specify it, it will use a new line for the second print, but the first one, this is actually just empty, so it won't put anything at all at the end if we run that. Right, so we end up those on the same line. And also, I did this on purpose. Make certain you're careful about space and stuff. So if I really wanted a space between those, somewhere I'd have to put a space like a space at the end or a space at the beginning. Okay. And as another example for the delimiter here, so the default delimiter is to put a space between stuff. So if you give multiple parameters, it will stick a space in between each parameter that you print there. Okay. So we actually end up with one space between every one of these that we print. But we could change that to, if we spell it right, to use X instead of space in between everything there, right? So sorry about that. The actual name of the parameter is separator, not delimiter. So the delimiter is what's going to be in what you specify to be the separator between the stuff that you print there. So if we specify the separator, we will get whatever you specify instead of X's, right? Or instead of spaces, which is the default. And then finally, I do want to mention these videos doing more sophisticated formatted output using what are known as F strings or formatted strings in Python. So we previously have kind of had a problem that, for example, like if we wanted to output hello name with no space between a person's name and the exclamation point, we couldn't do it. Or we could do it now that you know about the separator parameter that we had to print. But so previously, we would be forced to do something like, so if the name is Alan Turing, if I wanted to print it out like I was showing, right? Here we're going to have a problem. We could use the separator. We could explicitly add a space. So here, without this, we'll get a space between everything, right? Like we were just talking about. So I could use that separator trick that I was just talking about to have no separation between there and explicitly put in only a space where we need it, right? That gives us the correct result. But the way that you really should be doing this when you get anything more complicated than what I've just shown is you should be using a formatted string or an F string. So for these strings, whenever you have anything between the curly braces, it will look for a variable of that name, and whatever values in that variable will get replaced. So everything between the curly braces will get replaced by the value in the variable. Right? So we should get the same result of, I forgot to close off the string there, of what we want. So we have no space between the punctuation, the space between the hello and the person's name that we're trying to print out on the output here. So, our textbook goes into a lot more details of this. I'm not going to mention 2 or 3 things about F strings or formatted output that will be the most useful for the next 2 or 3 assignments that you're going to be doing for the class. Okay. Even our textbook doesn't show everything you can do with formatted strings. The PEP 3101, if you want to go to that link here, I'll have that link in the the video description as usual. Gives you, I think, probably everything that you can actually do with formatted strings. Okay? So one thing that you will need to do a lot in this class. So often when we're displaying numbers, like if a number represents a value in dollars and cents, we want to round it off to 2 decimal places, and so only show 2 places after the decimal point for cents. Right. So we can do that. So anything after the variable name after a colon is what's known as this format specifier, right? So there's different letters for F for a floating point, D for a decimal, which is an integer, or S for a string are the 3 that you should know most about, okay? So before I jump over to the example here, another important one is the field width. Okay, so again, if we're trying to format like a dollar amount, if for anything, lots of time we need everything that we're formatting to be in a field with a particular width. Okay, so like the first thing usually after the colon is going to be the field width, right? So here when we say 12, there's going to be 12 characters that whatever this number ends up being are printed in. Right. So in this case, 2 of the digits will be for the after the decimal place. 1 of the fields in the field width has the decimal point. So that leaves 9 to display the digits. Although here we're showing another modifier that's useful when you're displaying dollar amounts for Americans who use commas between every 3 numbers. Right, so if you put a comma there, it will separate hundreds, thousands, and millions by a comma, which is another convention when you're displaying dollars or big numbers in general. Okay. Okay, so let's show quickly some examples of that. So if we have a number like we had on the slide we were just looking at. So we have 4 decimal places here. If we print it out with that formatter, like that, we'll get it. So notice it's in a field here. So this is also useful for lining stuff up, right? So if I have another dollar amount or another number like that, so you can see that by default numeric value is going to be right justified, right? So we can line up stuff by the decimal point. Okay? So if the significant digits before the decimal place are more than 9 digits, it will it won't fit in the field, so it wouldn't line up anymore, right? So if I have a number. Right, so this is more than 9 digits. It will just push it over, right? So the field width has to be as big as or bigger than the largest number of digits that you want for the total, including the commas and the periods when you're doing things like this. So by the way, the default is to do right justification when you're doing numbers like this, and you can also do integer values, although it uses D instead of F. And I'm not certain why. Maybe I would have made more sense to me. So D for digits or something like that. So if I'm going to display a number, an integer number, or if I want to display even though it's a floating point number, if I want to display it as in a field with a 12, but as an integer you can use a D, right? So it will. So yeah, I guess I'm wrong on that. So you do actually have to have integers type, so it won't do the conversion from float to an integer for you automatically there. So if num is an integer instead of a float, it will do kind of the same thing, but in a field with a 12 here, right justified. Right, so if I have another bigger number, still it's less than 12 digits. These should line up right justified. So since I was just talking about justification, you can change the justification to be left, right, or center justified within the field. And the other thing I'll introduce is you can also, format strings. So a lot of the stuff that we'll work with for basic data types are going to be integers, floats, or strings. So you can use the S for if I have a string type that I want to format and put it in like a field and maybe justify it left or right. Okay, so so we can do kind of the same example I had on the slides there. So if we have like a name, and if we have a person's title, and if we have a salary, so in this case, the first two are strings, the last one is a floating point number. But so you can also left and right justify floating floats or integers if you want as well using that format, right? So here, anything before the justification is actually the fill character, right? So without specifying the fill character, it would fill things with spaces. Let me go ahead and show that first. We'll jump to that. So here we'll left justify the name in a field with a 20. We'll put immediately the title in a centered center justified in a field with a 40, and we'll put the salary in a right justified, and we'll round it to 2 decimal places. It's a floating point number here, right? So, if you don't believe what we did here in the slide I'd shown, you can specify the fill character. That's another thing to do. So instead of filling with spaces, I'm going to fill with A, B, and C for each one of these, right? So you can see that we left justify, and we fill any of the stuff in the 20 with A's. We center justify, and we fill anything to the left and the right, other than the 40 character to fill it into a field with a 40 with B, and then we fill this one with C that was right justified. So yeah, I mean, the floats and integers are right justified by default, so it might have been better to show this left justified again, or center justified. Right? So there, again, we left justified it, even though it was a numeric data type there. So this was generically what our textbook showed. That there's actually a few more things, like, for example, this doesn't show the fill character. The fill character would come before the alignment. Then you specify the alignment. Then you specify the field width. You can have a comma for numeric types in order to have it, group things by 3. I don't know if there's any way to specify, like, not all regions use a comma to separate into groups like that. And then dot with the precision, and then the type. So that's going to be S for strings, F for floats, or D for integers, actually, whole numbers. And one final format specifier, I didn't mention it in my slides, but the textbook mentions this. So for some of the assignments coming up, we might do some things with percentages. So normally when we're doing calculations, we'll enter a percentage in as a ratio between 0 and 1, right? So 2.5%, we would have it as a ratio of 0.025 to represent when we do a calculation for like a 2.5% interest rate, right? But often when you specify these in documents for a business or something, it's going to be printed out as a percentage, so a number between 0 and 100, right? So another format type that you can use is a percent to say that I got a ratio, but I want it displayed as a percentage, right? So if I do my rate, like that, even though it's a ratio, it should display it as a percentage. But the other things work the same as we showed before, so it'll give me 2 decimal places. Although in this case, well, all right, so it should be 2.5% is our interest rate here. So common mistake. So without the F, it's just going to be interpreted as just a plain literal, right? So you need to have that F so that the print statement knows that this is a F string. So it needs to be doing, parsing the information in here to replace stuff and format it as you specify it. So there's the interest rate of 2.5%. So one final thing in this video, our textbook at the very end of the chapter 2 mentions magic numbers and named constants. So, talked about variables and also talked a little bit about named constants. Okay, so magic numbers are things like this. There's unexplained numeric values that appear in a calculation. Right. So what is 0.069? Interest rate, percentage, who knows? Right. So magic numbers are bad for a couple of different reasons. They're not readable. They don't communicate the intention of what that number is doing. If you need to change that, whatever it is, interest rate or whatever, and you've got it in multiple places, you have to go and find all those, and you're always at risk of maybe missing one. So then you'll have some parts of your program using one rate and some others using an incorrect one that didn't get changed. Okay? So another is, if you do have to make copies of that, you always run the risk that I copy it wrong, or if I'm fixing it in places that I miss some of the places that have it to fix, right? So instead, so you might get comments and code reviews when you do assignments in this class that you need to name your constants. Don't use magic numbers. So instead, you should use a named constant. Python, basically you declare a variable, but the style is that you use the all uppercase snake variable. So all uppercase letters usually indicates by most people's Python style, and other high-level programming languages use the same style, that this is supposed to be a constant value. So these make codes more self-explanatory, better self-documenting code, and it makes it easier to maintain. So if I do have to change the interest rate, I can just change it in one place, and that should update it everywhere else. Okay? All right, so that's it for this video. So just to summarize a couple things that we covered today. So the input function allows you to get input from the user. So that completed our ability to get input, process it, and show the results, right? And then the other thing that we talked about in this is some more advanced ways of formatting your output. So you'll need to make a lot of use of the so-called F strings for formatted output in Python for our programming assignments to get things exactly right. So a lot of the tests for the assignments expect the output formatted exactly, including you have to have exactly the right white space, exactly the things in the correct columns and stuff in order to pass the test. If you don't, you won't pass the test until you get your output formatting correct. So it's important to understand and use the formatted strings correctly. So a couple of other things. So, we looked at some other built-in basic functions like int and float. So you can convert strings into numeric values, so you can use them in calculations. And we talked a little bit about calculations a bit. So make certain you understand operator precedence, and then how you would convert like a mathematical expression by the conventions of like algebra, how that, the differences you need in order to get that calculation correct in a high-level language numerical expression. All right. So that's it for this video. We're a little bit longer than I wanted to. I'm trying to keep these down to more like 30 minutes or less, 25 minutes or so. But that's it for this one. I hope these are useful for you. As usual, send us questions if you have them, and I hope to see you later then.